Welcome, everyone. If it's good morning, if it's good afternoon, good evening, we really appreciate you for joining this presentation. And the agenda for the presentation today is essentially quite an interesting one. We've got essentially myself from CluedIn, a data integration platform. We've got Mikkel from Teradata. Essentially, what we're trying to prove in this webcast is, two companies that are helping companies become a lot more data driven. What do they actually see out there in the market? How are these independent companies helping companies get value out of their data? And the interesting part about this is that either myself or Mikkel have actually seen each other's slides. So what's interesting about this is that what we're hoping to see is some overlap and some synergy in the in the ways that these companies are essentially solving this problem of getting data to the forefront of the business. I will start out. I'll introduce myself. My name is Tim Ward. I'm the CEO of CluedIn. I have been, alongside with the CluedIn team, been helping companies become a lot more data-driven for the last 4 to 5 years. And my goal today, as the first presenter of half of this webinar, is to essentially show you the types of discussions that we're having with our customers and our companies, and what's really resonating with them. If we're talking about how to solve the data problem, really what are the parts that these companies are really latching onto as what will be the solutions to help them solve this problem. It's probably a good idea to actually start with the problem. And for those of you who are on the call that have worked in enterprise businesses before, I'd like to just clarify that, you are not alone. You are not unique in this world, in this problem of the fact that at your business, the data is scattered across your company. And the quality of the data that sits across your business very much varies. And in some cases, some of these systems have got to a point where they are fundamentally broken in the way that you can't innovate to the same levels that the market requires due to technology, due to technical data, historical debt. For the last 4 or 5 years at CluedIn, we've been helping companies become a lot more data-driven. And through this, we have mapped a very common landscape of what we see at most companies, how most companies are trying to solve this problem. And I'm sure a lot of you on the webinar today would familiarize yourself with a lot of these different components. For example, it's not uncommon for a lot of enterprises to have a data warehouse, to have stories around data governance, to have storage, cloud storage, to have backups, archives, and recovery stories. We're seeing a clear abstraction in the market now when we are talking to our customers. And I'd like to use an analogy to help describe this. If you were a company today trying to buy a database, you would not go out and buy a separate querying engine, a separate indexing engine, and a separate storage engine. In fact, the database is the abstraction over that problem. And what we're seeing in the industry now is that it's time for this new layer of abstraction. And the way that we describe that is called the data fabric. The best way to describe the data fabric is essentially stitching all of the parts of the business that are necessary to become more data-driven into a consistent, accessible layer. And no matter how myself or Mikkel from Teradata solve this problem, I think we would both agree on one fact, and that is that it's so important to make data accessible to the business in as ready a format as humanly possible. And that's what we see as where companies are needing to move. This is spawned from the fact that when we talk to these businesses, the businesses do not seem to worry or care too much about what cloud provider are you using? What retention policy do we have on data? And to be honest, they shouldn't be thinking about this. They should be thinking about how can we use our data to apply to use cases to get value out of it. So when we talk to the customers and companies on the CluedIn platform, essentially the first hurdle that they typically run into is through data integration. And so most of our customers, when we talk to them, they're really looking into how can they abstract this problem away? How can they look into using a platform that has many pre-built integrations to platforms like Oracle, Salesforce, etc. Now, here is the problem. Some would probably argue that integration is an easy problem to solve. And time after time, when we're working with our customers, we see this as a reality, that most companies could probably integrate into most systems and have data flowing through within 1 or 2 days. Let's go with that hypothetical. There is such a fundamental difference between this type of integration to something that can stand up against the robustness that is necessary for the enterprise. And so where our customers, the kind of integration story that is resonating with them is, it starts with having to think like an enterprise. And one of the kind of discussions we typically have with these businesses is around authentication. So I can tell you without a doubt that the enterprise is not using usernames and passwords to integrate data. They're using enterprise platforms like SCIM, NTLM, Kerberos, single sign-on, certificates to actually authenticate data flowing throughout the enterprise. One of the things that's often missed in this story is the enterprise is also growing fast. They will also be adapting new methodologies of authentication. They'll be buying new industry standards around security and authentication. So your integration story really has to have it in mind that, does your integration actually support the ability to change authentication at the snap of a finger? You can imagine if we're trying to make companies data-driven, that the thought of data flow stopping because we have to change over authentication mechanisms, and that might cause 1 or 2 days of data flow that's interrupted. This is just something that's not accepted within the enterprise. One of the other ways that our customers are resonating in this area around integration is that we really need to be thinking about the whole enterprise, not just separate departments. And one of the ways that you can help solve this in the data story is through the use of service accounts. This is one of the ways that you can authenticate with systems to fetch data, but also to make sure that you are iterating over all of the accounts that sit within your business, not just pulling admin accounts, not just pulling individual accounts. This is really where the problem doesn't scale. So we also need to be thinking about the enterprise is growing, it's expanding and collapsing all of the time. So what about new accounts? What about new employees? What about retention? What about churn of employees? Does your integration story have the ability to actually react to new accounts coming on, potentially hundreds a day? And one of the most ironic things in the data kind of driven world is that integration of data needs to be fast, but not too fast. The problem, of course, if you have an integration story that has highly parallelized and highly distributed data processing, is that you'll wait 6, 8, 12 months before the data is even in the system. And to some business cases, this is unacceptable. On the other hand, these are usually production systems that you're integrating with. So there needs to be this perfect balance of not upsetting the production systems from being used in their day-to-day use cases, but also building a data fabric story that gives you the full picture of the business. And then one thing that always comes up is real time or not. Now, if we actually have a look at the landscape of most of the platforms that enterprises are using, so these are systems like Oracle and, of course, Teradata. These are systems like SAP, IBM, Salesforce, etc. Now, a lot of these platforms do support real-time data. But if we look across the entire landscape, there is a lot of more historical systems, whether they be mainframes, that do not support real-time data. One of the great things about real-time data is it means that we don't have to have these typical kind of crawling mechanisms that are constantly going back and fetching the new and updated data. So we can actually lean on real-time systems to be able to lessen the amount of these scheduled crawls of data across the business to be able to fulfill this data fabric story. However, we can't forget that a lot of these real-time protocols are based off fire and forget. There is no guarantee that you will actually be given this data. There could be network problems, etc. And the bottom line is, in the enterprise, network problems are always an inherent problem. So really, we can't base ourselves off using these technologies, because one important thing is that we need a holistic picture of our data. If we're missing data, this does not give us the true data fabric story that we need. And one of the approaches that is resonating with the customers and companies that we talk to is that there are 15 different types of database families today. And all of these individual families solve different problems. Some are targeted towards aggregating data for reports. Some are for being able to search across data. Some are for being able to discover connected data. All of these database families are designed to solve different problems. And just to take CluedIn as a case, we actually use 5 different database families to store the same data. What this helps us out with is not only being able to ask different questions of our data to help us in the cleaning and data preparation phase, but also when you're wanting to query data through your fabric, you have a very flexible model to be able to project out data exactly how the teams want it, whether that be the data science team, whether that be the business intelligence team. This is the kind of fabric we need to work towards. And one of the ways that we kind of help our customers understand their data is to go back to bare bones, to go and set a baseline of quality of data across their business. So at CluedIn, we always talk to our customers about scoring the data on different metrics. And at CluedIn, we use 6 different metrics to help measure this. The first is completeness, relevance, validity, staleness, quality, and accuracy. Now, Mikkel and I were talking before, and we all agreed that in the data world, these sound synonymous, but they're very much not. These are all different metrics to be able to score the overall quality of data that you are pushing out to the business. And this is something that is so fundamental that at the end of the day, it is much easier for a business to make decisions off showing what is the quality of the data they're sending out to the business instead of a black box. One of the interesting approaches that is resonating with our customers is this approach of using multiple database technologies. And one of the advantages that this brings us is in this typical problem of merging data across different systems. Now, if I was in the typical relational world and I was wanting to map databases into, for example, a data warehouse, I would need to be very aware of the referential integrity of where this data came from. So how it was related to each other. Well, this is something that the graph database has just solved for us. We no longer need to put as much onus onto the source integrity, because really at the end of the day, this is where some of the problem arises, that the quality of the referential integrity in these systems is sometimes questionable. Both myself and Mikkel spend a lot of time with our customers, and the bottom line is a lot of these systems started out with great intentions. The referential integrity of these systems were very sound. But over time, over people leaving and changing job titles, over adding new complexities and tables and things like this to those data sources, this referential integrity has lost its integrity over time. So one of the advantages of leaning on newer technologies, but different families of technologies, is that we can solve these problems in different ways now. Not to mention that there are many online sources of data. Some are free, some are paid. What we need to keep in mind, the same way that we're ingesting data from our internal systems, from these external systems, that data could also be inaccurate. It could be stale. It could be incomplete. So this same mechanism still comes into play, that where we get the data from, it's not as important as what is the metrics of quality and accuracy and the metrics you saw before. How can we use that to build much more confidence over how many different places are all alluding to the same type of data records? So this is where, at the point where most companies are at. They've been able to merge records from different systems with a classical ETL type of approach. And the way that this typically works is that we buy tools where we have designers, where we map different systems together, and we tell how the different systems overlap. This is fantastic. This is still a very valid approach to solving this problem. But the bottom line is that's not always how data looks. You know, we have to go with this in mind, that data will not be always in the perfect kind of quality in the source systems. And so I am very much a person in the technology industry that likes to see things tangibly working before I put my whole kind of heart into them. But with this type of fuzzy merging, where there is no unique overlap between records, there's no obvious way that we can sit here and say that these are the same records. This is one place where machine learning really shines. It's not about us coming up with rules of what determines if things should merge or not, what determines if things should be cleaned or not. It's about getting statistical confidence over, we can be confident that there's so much overlap between these records. And so machine learning and clustering is a very good solution to this problem. It's also important that as we're making these changes to our data, we're pulling in data from different sources, we're preparing it, we're cleaning it, we're trying to merge and deduplicate these records. It's very important that we're storing the lineage of this data, because more often than you would think, it's very important to be able to go back in the history of data and to be able to rethink about how things were cleaned or merged. So most of you to this point on the call would have been solving this problem in this classical kind of metadata approach. The bottom line is, other technologies can give us big hints into how we can prepare our data to serve to the business. I'm going to use the graph database as another example. If we now look at those two records we saw before on Emma Smith and Emma Fitzpatrick in the metadata type of approach, it was very hard for us to find obvious overlap. If we took the machine learning approach, well, that's going to get us some type of answers, but once again, it might not be obvious. If we start to look at the context around the data, you can start to see we can ask different questions about our data. It's getting much more relevant, it's getting much more obvious that potentially there is overlap between these two records. The graph also gives us other complex types of querying. For example, if I have these two records at completely different other parts of my business, the graph allows us to ask, shortest path questions. For example, how are Emma Smith and Emma Fitzpatrick connected? What we can start to do is to see what is the overlap in the business of how many things that Emma Smith and Emma Fitzpatrick are working on. Are they working on similar documents? Are they working on similar topics? Are they both in the same types of department? But the metadata that I have would not help me out with that. A big problem that we help our customers out with is the unstructured data problem. If you look into the industry right now, most are trying to solve this with what's called natural language processing. It helps us in this problem of being able to identify some type of context, but only within the context of the actual unstructured data itself. This is where using other technologies like the graph database to be able to look outside the document and look at the context around it, it can really help us solve this problem to a stronger precision. But there is no magic. Even with current day technology, there's only so much that we can automatically fix and prepare out of data sources. And for that, the things that we kind of subscribe to our customers is there's a manual piece to this as well. And the way that we describe it is there's something for the data engineers to do or the data governance teams, and then there's something for the business users to do. It's very important to highlight that to solve this problem of being able to get value out of your data, there is a technology piece and there is a business culture piece. The technology piece is very much targeted towards the first interface that we give to our customers, CluedIn Clean. You can think of CluedIn Clean as a way for CluedIn to be able to tell the business, here is the data I was not able to automatically fix. This helps data engineers like Mikkel and myself to be able to fix things like telling a system if TX refers to T-Rex or if it refers to the state of Texas. This normalization of data will help data science teams, business intelligence teams have much more prepared data when they're ready to consume it. From the other side, the business users can also help. So for this, CluedIn uses a system called CluedIn Train. Think of it as a way of surfacing questions to business users and to answer simple yes or no. This is not about correcting the data. This is actually using a machine learning technique to help us over time improve the automatic piece of cleaning. Essentially, you're telling a system, did it do something right or wrong? It's also important to make sure that we're measuring this. So what we tell our customers is that, like you're measuring the quality of the data, you need to give the business some idea of how much work is involved in them getting up to the service level agreements of quality of data that they would like to serve to the business. So think of it like bringing up a child. It's not about always correcting the child, but telling them that it did something right or wrong. Let's take an example. If I was to tell my son, don't touch a knife, but you can touch your teddy bear. I can guarantee you that if I tell him once, there's a chance he's going to touch the knife. If I tell him 15 to 20 times, he may still statistically do it, but chances are if he touched the knife and got hurt, then he would never do that again. It's the same type of approach, but with data. Not to mention, if we're leveraging different types of technologies, including databases, there is different ways to explore data that can make it easier for us to fix it. So something like visualizing our data in a network view, think of it like the Facebook network or LinkedIn network. These are ways that we can fix data that tabular views of data will just not help us with. So as I kind of gave a vein throughout that presentation, it's important that every step we're evaluating how we can measure the quality of data across our business. Now, obviously, we're at a point now where we want to utilize this data. And in my mind, when we talk to our customers, there is no more modern day query language that suits this better than GraphQL. GraphQL is an MIT licensed query language that was built out of Facebook. And where it makes complete sense is that one single query can actually be resolved by multiple different systems. And in our particular case, that might be multiple different databases. The idea being that I can be very flexible in how I get my data out of the data fabric, but I can also make sure that these queries are optimized, that the right database runs the right part of the query. Not to mention that you can also use this technique to be able to subscribe and listen to data. You don't go far in the data world without hearing about streaming services. So to be able to use this service to listen to data across your business and potentially push it over to business intelligence tools immediately, to be able to make sure we have as much real-time data-driven decisions as we can. So in my mind, when we talk to our customers, this is what is necessary to help a customer become data-driven. We refer to it as a data fabric, and the best way to visualize it is data comes in a certain format. Once pushed through the data fabric, it comes out in much more a usable, enriched, ready to use for business use cases. So now I'm going to hand over to Mikkel. Mikkel's going to essentially talk about his experience at Teradata in how he is working with data there. Mikkel?
Thank you, Tim. I don't have any slides, so I'm going to, you can just sit and listen to my golden voice on this webinar. To follow up on what Tim was just talking about is, you could say that his talk was about how do you get your data in order? How do you get data from all the different systems together in a way that you are able to start asking questions of your data and to start to become more data driven. Just combining your data, of course, into an easy source to access is not how you get the data driven only. You also need to be able to do some data science on top of it, to ask the right questions, to do the right analysis. If you look at the engineering part of the data and data science world today, you see technologies like serverless and containerization on the move. And what they essentially want to do is to make it easy for you to get started with doing your building up your infrastructure. And also in the same way with data, I think one of the most important and probably one of the most underlooked parts is to make it easy to use data. And there are probably two key aspects here that people or companies should be aware of when they want to go down the journey towards data science and to become data driven. One is it easy to access your data? And one thing could be what Tim just talked about, having multiple data sources and combining it into one data source. But there's also the question of having access to this data source. Then in the end, do you have permission to read the data and so on? And a lot of time I see data science team and data scientists, both internal and external consultants in companies, spending so much time trying to get access and the right permissions to just even view the data. So if you are going to start down this path, I recommend that you think very hard about how can you make it as easy as possible for your people to get access to data. And there are some things you should also be aware of, is that also how well is the data described, what is actually inside the data. There was or still is in Denmark, a large movement towards more open data. You see municipalities and other institutions giving out their data openly. But a lot of the time, at least in the beginning, the data was not very well described. And you have the thing about garbage in and garbage out with data, meaning that if you have rubbish data coming in, then you have rubbish result coming out the other end. But also you could have the most stellar perfect data coming in, but if nobody knows what the variables are about, you're also not going to get any good results out in the other end. So think about how you can make it as easy as possible. I sort of like the Netflix approach to how they do stuff. I saw a talk on how they allow everyone to see anything, and I like this view, but I'm also very like a semi-revolutionary contrarian, and I think a lot of at least traditional IT departments will have a very hard time with this. But and they get questions all the time like, well, if you let people have access to anything, and they would just break stuff. And like he says in this talk, it has never happened. Like in all the years they've done stuff, it has never happened. Another thing that they're also pioneering is the whole use of microservices. I mentioned containerization before, Docker and so on. And I see the point of microservices as having a well-defined space and area where you can do your stuff. So in a microservice pipeline, you would know what would come in to your microservice and what you are expected to give out. But how you then solve it afterwards in your own microservice, that's entirely up to you. And I think that's also an approach that many companies can learn a lot about, like tying all your Python developers down to using only Python 2 when all the new and cool stuff is happening in Python 3. How can you avoid that? How can you set up an infrastructure where your data scientists can work in their language of choice, just having to be aware of how they get data in and what they're supposed to give out on the other end. Before the summer, I actually did a little proof of concept with a colleague in Teradata where we set up what we called a functainers. So it was a data science pipeline using multiple Docker containers, but they were running, each was running their own language. One was running R, one was running Python, and so on. But they were piping stuff into each other, which and the concept here was, if you have a data science team with different competencies, don't force them all into to one language. Make them develop in the language that they like. And then I would also say one of the things that I run into is that sometimes the data engineers or the business owners, they give the data scientists data that's already been aggregated. So I actually kind of like what Tim was also showing, that they keep sort of a full history of all the data, because sometimes you just need to go back, and sometimes the data on the aggregate level is not good enough. You need to take one step further back to have your algorithms work properly. And then we just, before we started the webinar, we also had a little talk about like what to do with GDPR. And here I actually think that instead of having your data science team debate day in and day out with legal department about what they can see and use and so on, then define a version of the data set they need to use that is GDPR compliant. Pull out that stuff that is interfering, and then just have like a sort of a more free and open data set if it's possible. It will make it easier for your internal data scientists to work, but it will actually also make it easier if you hire external consultants. They will be able to get to work straight away without too much legal problems. So now that we have talked about how you would get access to data and maybe how you would sort of set up your infrastructure, how would you then go about it? Data science, for me, is about helping the business with their questions. And I also think that maybe that is where data science to some degree is falling short sometimes, is that they don't have a clear goal on what they're supposed to do in the business. A lot of it's a hyped word. Since I changed my title to data scientist a few years ago, I've never had so many requests on LinkedIn as I do now. So just from that metric, there seems to be a lot going on. But also, and from that same metric, by the way, you hire in these data scientists and they get offers from everywhere, so they are also quite expensive. So you as a business, you want to get value out of these data scientists. And that's also to come back with, make it easy for them to get started either with the language they want and have them access to the data they need, but then also lead them in the right direction, because data scientists, we want to explore everything, and we will jump down the rabbit hole, and we will do all sorts of fancy analysis with all sorts of amazing algorithms. And once we come back up, it might not have been the answer to the business questions you were looking for. So it's very important that you get buy-in from some companies. Sorry, from the stakeholders in your company. I can give a concrete example. I work for a large Danish festival in my free time, where I run the data science team every year when we have the festival. And the first year we did some quite interesting analysis of what was going on, but it was totally driven by our data science team. And once we had done them, then we showed them to business people, and they said, it looks very interesting. What are we supposed to do with it? And well, we couldn't answer that because we were not the business people. But shortly after that, the crowd management part of the festival came and asked, we need to know how many people are entering the festival. Is that something you can help us out with? And we actually do have data for that. So we said, it's very easy. We can set up a monitoring system and you can get the data you need. And from that point on, you start giving value back to the business. But you need to have the business also ask the questions that they want answers to, because your data scientists, well, they can't figure this out on their own. And this also leads to two other points of mine in this regard. One is, you need to have subject matter experts along for the ride. By this, I mean people who know the business, who know what is going on, who know what is hidden in the data. I worked for a large company once where we were going to, every time something happened in their production system, it got registered with a different type of scan. And when we started out, I was only talking to sort of middle management who wanted to see, they had the questions, and they were interested in, you know, seeing the results. And they said, we only need to look at these 10 types of scans. But before we were over, maybe 3 months later, we had identified, I think, close to 70 different scans. Codes they didn't know were there that had a big influence on how we were measuring the system. I know it's a little bit abstract, but it's because I can't tell you who the client is. But at some point, they found this guy down in the basement, at least that's what I'm telling myself, who knew all about these scans and all about these codes. And once he got in on the project, it helped a lot, because your data scientists, they can do all sorts of advanced stuff with algorithms and data. But if they don't know what the data is about, they can run down, they can run in a wrong direction. So this is where you need to have the subject matter experts along. They need to be able to answer the questions that your data scientists have, and they will have questions. If they don't have questions, you should be worried. The second one is this with the stakeholders. As I told you in the festival, once we got a stakeholder on board who had the business questions, you know, it gives your data scientist direction, but it also gives them something to test ideas up against. Maybe you want to build this rocket ship or this Ferrari of an analytical engine that can predict the future in any way you want. But as soon as you have this a basic frame with the 4 wheels on it, put your stakeholder in it and ask him to take it for a test drive. The reason why I'm saying this is I have noticed a few times that companies and data scientists, they start building very, very big and very, very elaborate projects, and they don't get any user feedback or stakeholder feedback until the very end. And if you have ever written software or code that was meant for others to use, well, the first thing users do is they start breaking your stuff. So let's have them break stuff early. Also have them, the stakeholders tell running in the wrong direction, because it's much easier to change course incrementally along the way than to have to rewrite half of the code base once you have your semi-finished data science project. And then of course, well, in the startup world, they call this the minimal viable product. As soon as you have something to show it and get some feedback on it. And there's also, and this is where I actually think data science teams can learn a lot. There are so many great things coming out of software development that data scientists sometimes do not use. It is, of course, just basic stuff like using Git, for instance. A lot of data science teams don't even do that. But it's also, for instance, having stand-ups and reviews, the whole Scrum methodology. And once you realize that writing code for data science is akin to writing code for software projects, there's a lot of great books and tools that you can start using, and it will make it a lot easier. And also on these stand-ups, if you don't know what it is, it means you meet every morning or sometimes every afternoon, and you talk about what you did in the previous time and what you're going to do in the forthcoming time. It sort of keeps things on track, but it can also make you align better with the stakeholders and with the subject matter experts. So it's a great opportunity to get everyone involved. Then finally, I would say be flexible and be willing to iterate. That's how you get a good data science product. And once and also with the way that I propose that you get stakeholders involved is to solve the lowest hanging fruits first. Because if you can start sort of immediately showing value, then the people who are paying the bills will of course be happy, but it will actually also make more parts of the business interested in what you have to offer. You will get the data science team will be more valued. And what always happens with data is once you answer one question, you get 5 new ones out of that question. So it's also, I mean, get started with the lowest hanging fruit, and then it will sort of solve itself. But of course, like Tim mentioned in the beginning, you need to have data, and data needs to be in order. But if I can go in the helicopter a little bit and look down on our 2 talks now, there is a clear path about having all your data and your fragmented data and putting that together, both ensuring that it's good quality, but also in a way that makes it easy to use. And once it's easy to use, then start having the business people become involved with the questions they need answers to. And then if you have those 2 ducks in a row, if you have good data that's easily accessible and good questions that are relevant for the business, then you have a very good start for your data science journey, I would say.
Thank you very much, Mikkel. For all of those on the webinar, feel free to continue to ask questions in the GoToWebinar interface. I have 3 already, and these are mainly targeted towards you, Mikkel. So good luck.
It's the exam now.
Yeah, it is. Yes, let's see how you go. So did data science then happen too early? Would you recommend that companies actually maybe get their data story in place first? So I guess the highlighted question here is, did data science happen too early?
I don't think it happened too early. I think the parts where it went wrong is that data science is a buzzword and people just want to get on board. And I also think for the engineers who have been working on big data infrastructure, like people were also talking a lot about big data, and big data would solve everything. But actually a lot of companies didn't even have big data. Like you could probably put everything in an Excel sheet. So it's more or less, it's a tool, but you need to know what to use it for. And then also because it's a starting industry, and I think I actually found out, this is just like a little thing, that it got started by LinkedIn. that they had a lot of people who had like different sorts of analyst titles, and they were getting ready for their IPO, and they needed to clean up the organizational chart. And then they invented the word data scientist to sort of cover all of these positions to make it more uniform, which also just shows you how arbitrary it is. And we're talking about it like this concept now, and you can actually get educated as a data scientist in Copenhagen, and it's just something they invented over at LinkedIn.
So maybe it's not that it's too early, it's that it came in at a time, and now it's figuring out its problems.
Exactly, and it's figuring out how to what legs to stand on, and how to be used, so to say. And no company is the same, so every company needs to find out how they can use data science.
So the next one is the win that has come out of taking a machine learning approach, in your experience, yielded wildly better results than what companies are doing already? Do you want to read that again for you?
No, but the question is, it's an unanswerable question, because it depends on it totally depends on the business and what they were doing before and so on. Sometimes you will have data science and machine learning algorithms doing incredible stuff that you were never able to do before. Humans are the best ones at pattern recognition and so on. So in some cases, if you need to have a pattern recognized very fast, then of course it's amazing. I told you earlier also that if your machine learning algorithm start finding out stuff that is totally contrary to what the old school guys in a company believe, then probably the machine learning algorithm is wrong, because it's hard to beat 20 years of experience. Where I think data science can help is in two regards then, where it really shows value. One is that it can quantify stuff a lot better. It can tell you, if you move X, what is going to happen to Y. The old school guys, they have a gut feeling already that there's a relationship between X and Y, but they might not be able to quantify it. And the second is that it's the speed thing, that because it's on a machine and it's an algorithm, you will be able to use this like a lot faster than having it manually done by people.
Before I ask the third question, just a comment on that. A lot of the things that we're seeing with our customers is that really we've got it to the point where they are using machine learning, and now it's hard for them to quantify it, because a lot of our customers use us, for example, for helping them in the sales process, to be able to detect, will this lead turn into a paying customer? And of course, the approaches that most of those companies are taking is to use historical data that has been essentially marked up with this customer bought, this customer did not, and to use machine learning techniques to basically build up clusters. So when a new lead comes in, which cluster does that fall into? Well, my team will actually then focus on those clusters instead. I think the hardest challenge for people right now that are at that point with what we see is trusting the system and going down a path which might necessarily match their gut feeling. And in your recommendation, in your experience, would you actually say, how much do you continue with gut feeling versus embracing the data-driven approach instead?
Well, I also believe in sort of the scientific method. So I would, if the company was willing to do it, I would put up some sort of A/B test. I would have like randomly split your sales team into two, have one get leads from like an old school way of doing it, and have the other half get leads from the new way. I do a lot of stuff with politics. I'm actually a social scientist by trade, or not by trade, by education, and I'm very interested in the political process. And of course, we are always interested in. We just had a municipal election. We are running into a general election here in Denmark, and people sometimes ask me, "What works? Does it work to have posters up?" And I say, these are actually, and it's quite sad. It's some of the questions we have a hard time answering, because if I came to a candidate and said to him, I think this is a good approach. If you do this, you will get more votes. And then I follow up by saying to him, but I only want you to do it in half of the constituencies, because I want to test the effect. he would say, no way, I'm going to do it in all of it. So there's actually a lot of time when you would want to have A/B tests where people are just not doing it. This is political is a very good example. I don't know the company. Maybe you have a company who would say, we spend a lot of money on the data science team, so you all have to do it. But I actually think that, and we were talking about machine learning and all of that stuff about having a test and train set and maybe even a holdout set, and these are some for you who don't know, it's a way of not training your algorithm on the entire data set, but having some data set left out that you can test on to see if it really was a good algorithm that you built. I think this approach would also a company should try, and if they have if they have it in their DNA to mix up their teams in this way, and people feel comfortable with that. But also, I'm just going on a rant here. Imagine you had a sales team and you split it up into two, and you tell one sales team, oh, you're going to get help from the most advanced algorithms in the world, and the other team, oh, you have to fend for yourself. That could also create some problems.
Very much so.
Yeah. So you would need to find out how to do it in the right way.
There is some reality, and I guess that's what I'm touching on as well, is that, you know, for some of our customers, we've helped them with sales paths. How many times do you call? You know, should you call less or more?
Yeah.
And it comes back to that, well, are you going to trust a system to say, call this person 6 times? I mean, the bottom line is, what if the last phone call was awkward? What if it was left on a sour note? Does that mean that you should continue because at that lucky 6 number, according to this algorithm, that is going to turn around for some reason?
Yeah, I agree.
So it's very hard to quantify. I'll move into the last.
No, but I just before the last question.
Yes.
This is where also insights from a subject matter expert could come in. Like if a subject matter expert, a very good sales representative could say, I think it's an important metric that we register. How did the last talk go? Was it on a good note? Was it on a low note? And so on. Because it's my experience from 20 years of selling that this is important for the next call.
Yes.
And then the data scientist could say, okay, how do I get that feedback in? Can I put that into my algorithm as well?
And that's a good point. And how many companies that you run into have that type of mentality, but also infrastructure in place that after every experience, there is some type of human scoring or of course, without them knowing it's being fed into these machine learning algorithms, but you know, there's so many human factors that make this a very hard problem to solve.
Hardly any.
Yeah,
I don't see it anywhere, and I see it. I mean, also because no, I don't know, but it just like with the data science having to find its own legs. The other departments, the other people also have to find out how to interact or deal with data science to give this feedback to sort of be a part of the whole process.
Yes.
I see it on some where we are not putting things into production, but when we are sort of helping companies just trying to get insights. There it's a lot more, and maybe that's also because of the scientific method or what to say that it's a we can change stuff from day to day. It's probably a bit harder to change things once they're in production. But with this from day to day, getting the subject matter experts involved, and I think there we have a good dialogue where they come back and say, or I come back as a data scientist saying, I feel a little bit uneasy about this. Could there be something else that we need to know about? And they say, maybe we should find out how the last call went, for instance.
Perfect. So the last question is, if a company has invested in data science, what are the signs that it's working versus not working?
That the stakeholders in the business are happy. I would also say, of course, you could say that your data scientists are happy, but from like a general perspective, from a data science or from a business perspective, are they solving problems? Do I feel that now that I have spent all this money building this incredible team and giving them all the crazy servers and compute power that they wanted, am I then seeing any results at all? And this is just where it comes back to my point in my talk. 2 things. One thing that has 2 effects is that if you have a stakeholder with clear questions, hopefully questions that you can answer. Then you get a happy stakeholder, but you also get a happy data scientist because they feel they're contributing. They feel that they are solving real problems and not just running up against the wall with some algorithm. So
perfect. Thank you very much for your time, Mikkel.
Mm-hmm.
And thank you all for attending as well. As part of our ongoing webinars, we run webinars once a month. Next month, we will have Core from Implement Consulting Group, where he will be talking about essentially his experience with talking to top 50 customers around Denmark and how are they utilizing data? How are they solving things on their side as well? Sorry, we have one more question. So the final question, Mikkel, I think this is for you as well. So is it the data scientist that needs to be more commercial, or the commercial guys that need to be more data driven?
It's both, but I want to say that I've done a lot of stuff in my life. I have not always been a data scientist. I've been other things as well. And when I worked for the Danish Bankers Association back in the day, I also worked within the intersection between IT and finance. You could also call it IT and business. And one of the things that always came up was IT should have a business understanding. It's this interdisciplinary thing. The better you sort of understand each other, the easier it is for you to help each other out. So of course, if you as a business person don't become an expert on data science, but read some easy to understand book on it, so you have the general concepts, and then engage in a discussion or conversation with your data scientist. Also hire data scientists who are not just madly in love with the TensorFlow, but who actually wants to solve the problem of your business, who want to be a part of your business and make it shine. So of course it's like it goes both ways. If you really need this super expert in deep learning who is just really bad with people, then get a manager for him who understands what he's saying, but who can also talk to other people.
Good.
So
thank you very much. So excellent. So thank you once again for all attending. If you would like to talk to the CluedIn team about something that both myself and Mikkel touched on, which is you need to get a good story around your data first. You need to have accessible data that you can give to your teams. Feel free to reach out to us at CluedIn. You can visit us at CluedIn.com. If you're interested in actually doing something once you have that data, please reach out to Mikkel. These slides will be sent out after the presentation, and a recording of the webinar will be sent to all attendees as well. I hope you all have a lovely day. Thank you for joining us, and we'll see you next time. Thank you.
Bye-bye.